Okay, this is a continuation of Cramer's rule. Again, this was our initial matrix. We had 2, 5, 1, and 4. Our vector is x, y. Those are our two variables, and our answers are 7 and 2. So 2x plus 5y equals 7. 1x plus 4y equals 2. Remember, that's where we were. Now, we already found the determinant of a, which was, this is actually a times d minus c times b. So it's just these two crossed, multiplied each other, subtracted by that. Now, what I showed you at the very end was this. Now, recall that Cramer's rule assumes some things, and the first is this. He assumes that this is our equation. We have ax plus by equals e, and cx plus dy equals f. So really what we've got here is this. We've got matrix A, B, C, D, vector xy equals vector ef. The determinant was a times d minus c times b. Okay? But now we have this x and this y. So let's look at that. What we're really looking at, remember, this is E here, this is F, this was A, B, C, D. Okay, so what we're doing is we take EF, which is the solution for X, we put that first, EF. BD is the Y. So we have the solution and the Y over the determinant of A. For the y, we have the x values, a and c, and then the solution over the determinant of a. Now let me show you how this works. What we do is we find the determinants of these. So our x in this case will equal to, oops, let me go with a darker color than this. Our x will equal to e, which is 7, f, which is 2, b, which is 5, and d, which is 4. So that matrix over the determinant of a, which was 3, and then y will equal to a, c, which is 2, 1, and then our solution, 7, 2. Oops, ignore that, over 3. Now, if you look at this, what we've got is we've got two additional matrices, and we're going to get the determinants of these, okay? So now we're going to take these two, multiply 7 times 4, subtract 5 times 2, and then divide the whole thing by 3, and that will give us x. Y is 2 times 2 minus 1 times 7, all divided by 3. Now this seems really long-winded, but it's actually a very quick way to determine a solution. So now our x is equal to 28 minus 10 divided by 3. Our y is equal to 4 minus 7 divided by 3. X will equal to 18 divided by 3, which is equal to 6. And y is equal to negative 3 over 3, which is equal to negative 1. So our solution is 6 comma negative 1. Now, while that may seem long-winded, if I would have just gone ahead and gotten the solution, I could have done it very quickly. So let me give you an example of a second matrix and how it can be done relatively quickly. Okay, now I'm going to take a different matrix now, and this one is going to be, I'll take the problem 3x minus 2y equals something, we don't know. Let's see, equals 3x minus 2y equals 10. and 2x minus y equals 8. So those are my two equations. So now I have a matrix, 3, 2, negative 2, and note the negatives stay with the 2, minus 1, a vector x and y equals the vector 10 and 8. My determinant of A is going to equal to 3 times negative 1 minus 2 times negative 2. So this becomes negative 3 minus negative 4, which is equal to 1. It's like negative 3 plus 4. So we have a determinant of 1. That's a great determinant because easy to work with. Okay, now what I need to find is my x and my y. My x was my E and my F, so it's 10 and 8, and then my B and D, negative 2, negative 1. And that's over my determinant, which is 1. My y is my x's, 3 and 2, and then my solution, up 10 and 8. And notice my y is the second number in my solution, and so the solution goes second. X is my first, so the solution goes first. That's how I always remembered it. So now my x is equal to negative 10 minus negative 16. 8 times negative 2. My y is equal to 24 minus 20. So now what I have is an x, and that becomes a plus that's equal to 6, and a y that's equal to 4.